All right, let's get started. Okay, so PS5 is out. And due the end of the week. I want to do a little demo for you to just to explain a few things about PS5. I'll do that now. So what it focuses on is this problem of taking the text from a book and then generating random text based on the probabilities with which characters occur in that book. And this is all explained in the assignment in a problem set write-up, and it's not crucial to understand all the details of how it works. So I won't get into that here. I just wanted to show you how the pieces are supposed to operate. So there ended up being 3 parts to the assignment. There were just 2 before the weekend, but over the weekend when I was setting up the way to submit stuff to Gradescope, I realized I needed to have separate submission for 3 different things. So I didn't add to the assignment, I just added to what you have to do when you submit. You have to submit 3 things. So one thing you have to submit is a graphical user interface, a simple user interface that we're looking at here that lets the user interact with some methods you're going to write. And when you submit that as part of PS5B, or as PS5B, part of your grade will come from unit tests that get run against your user interface. And I realized after looking at the first few submissions that I didn't emphasize enough that it is necessary to follow the guidelines, the directions to the letter. So in the assignment it says, first do this, then do this, then do that. You got to do everything in the right order exactly as specified, or the testing screws up. So let me show you what I mean here. First thing it says to do is to prompt the user for a level. It has to be a non-negative number. So if I type a negative number, what's supposed to happen is it pops up a message that says, it doesn't matter what it says, but it basically tells the user they made an error and lets them try again. And then if I type something that's, I do a bad thing again, I say okay, I get that. If I type in a negative number, I get that. If I cancel, program ends. So let me run it again. When I enter something right, like level 8, what it needs to do now is to prompt for length. So I'll say okay, and it starts prompting for length. If you decide it would be nice to put in a pop-up that says, okay, you entered 8, that's good, and then it asks for length, it won't work with the test cases. Okay? You can't stick in extra boxes popping up. So once someone enters the correct level, then you ask for the length, and the same guidelines apply here. If I type something that's not a number, it'll tell me about it and ask me again. If I type in a negative number, it'll tell me about it and ask again. If I cancel, that should end the program. And it shouldn't pop up a message that says program ending, it should just end. And when I finally type something good, like 300, it should say, well, it shouldn't say anything. It should go to the next point, which is I got to choose a file. Okay? Now from this file dialog, if I click cancel, program should end. If I specify a garbage file, doesn't exist, and I say open, it should give me an error message and try again. And if I actually browse to a good file, so I'm going to use Pride and Prejudice, then it should run the program. At that point, it's got the data it needs. It's trying to get 3 things as input: a level, a length, and a file. If all those were good, then it runs the algorithm, that's another part of the assignment, and generates random text. So that's randomized text generated from Pride and Prejudice. So you won't find those exact sequences of words in Pride and Prejudice, but you can look at it and it sort of makes sense. Okay? And then when you're all done looking at the output of the program, you click OK and the program ends. So just do everything in the right order and don't pop up any boxes that aren't called for. Yeah.
What should it?
Okay, so let's say I pick level 8. I say I want 200 characters of output. And then it pops this up and I go pick like a PDF.
Okay.
Now, for some reason I thought that was too short. Yeah, I didn't ask you to do any check about that. So if they pick a file that doesn't make any sense to pick, it should be a plain text file. But if they pick the zip file here, see what happens. Now, I don't know why I keep saying it's too short for the level, but whatever happens, happens. Don't worry about it. Yeah, doesn't matter. Okay? So that's part of the assignment, is to write that. Another part of the assignment is to, what I give you is, so when those 3 pieces of data are entered correctly, then a method called generate text needs to be, your user interface needs to call the generate text method, which I have provided for you. That generate text method depends on 4 simpler methods that you need to implement. So part of the assignment is implementing those 4 methods. And the methods exist independently of the user interface, and you'll submit the Java class file containing those 4 methods as PS5A. And it'll be graded like you're familiar with. It'll run some unit tests against them, and then the TAs will look at it. So that's A and B. You can do A without doing B, and in fact, you can do B without doing A. Because when we test B, we're going to take your user interface, but we're going to hook it up with our implementation of generate text. So even if you can't generate text properly, you can still get full credit for the generator as long as the user interface part's correct. And then the last part is I'm requiring you to write some unit tests for the 4 methods, and you'll submit those unit tests as PS5C, and then we will see how good your unit tests are. And the way we do that is we take, I have 1 correct implementation of the 4 methods, and I have 10 incorrect ones. And so what I do is I have 10 test cases, and what each test case does is it runs your unit tests against the correct implementation and makes sure that all the tests pass. And then it picks one of the incorrect implementations and runs all of your unit tests against it and makes sure that at least one of those tests fails. If that happens, then that test passes for you. So it's a little bit hard to think of because we've got unit tests running unit tests. Okay? But that's how I'm grading unit tests. Okay? So if you haven't looked at the assignment yet, this probably didn't make a whole lot of sense, and there's nothing I can do about that. But are there any questions I could answer? Yeah?
No, sorry, this is for PS4. When are you going to post up the top 15 animations and stuff?
Oh, for the animations, we the TAs are grading it, and as they grade it, they pick the best ones, and so it'll take a few weeks. Yeah.
On the PS5, the A part, there's a couple places where it tells you to throw exceptions. It doesn't really say what it wants us to do to catch those. So is there something it wants us to catch those exceptions?
Okay. So he's asking, I say write this method, and then when this circumstance occurs, throw such and such an exception. And he's asking what you do about catching the exception. Well, the answer is it's not your problem to catch the exception. Whoever calls the method will catch the exception. You're just responsible for throwing the exception. Same thing when you write a method that returns some value, you don't worry about how that return value is going to be used. Someone will call the method and use the return value. Same thing with the exception. So just write it to throw the exception. Yeah?
So if we don't have to worry about that, so on the test case, we have to
Oh, certainly.
write it out,
Right. So when you write test cases for those 4 methods, you should include test cases that make sure that exceptions are thrown when they're supposed to be.
So if I, let's say, first start a program with the A part, and I just start catching them and return some level, and then on the test case, I kind of use that return level. Is that too much about do you understand?
Well, no. So if you're writing a method that says it's supposed to throw a no such element exception when the scanner is empty or something, when the string is empty, You just need to write a method, make sure that in the condition, when the right condition occurs, that it terminates the method by throwing a no such element exception. Period. Then your test case would call the method and make sure that it throws an exception when it's supposed to.
So on the A part, the throw, catch, and
Right. If you're catching the exceptions that you throw, so if you write a method that throws an exception and then you wrap a try block around it inside the method, the exception is not effectively not being thrown. It's not. The method needs to terminate by throwing an exception. You throw the exception in your methods, you catch them in your test cases, is a good way to put it. Or another way to look at it is you throw exceptions in those 4 methods you're writing. The generate text method, which I gave you, catches those exceptions.
so we shouldn't like catch it.
Right. Don't catch if it says throw an exception, throw it, don't catch it. Any other questions? Okay, if you get to the point where you're doing the generator class, which is the user interface, and you're failing test cases for mysterious reasons, come back and look at the video of what I just did and make sure that you aren't popping up extra boxes or forgetting to pop up boxes. Yeah?
How do we access that video?
There's a link on the very front page of the Canvas homepage. Videos or YouTube or something. Okay, a couple other things you need to be aware of. You've got to use dialogues, the dialogues class for user interface. So everything you saw popping up, it needs to be dialogues.showMessageDialog. There's a method for popping up of the file browser. There are other ways to do it, but they won't work with the test cases. Don't use JOption page. Don't use the, don't write to the display directly. Don't write to standard out. Just use the dialogues classes. And another thing is, there are directions that will say, okay, if the cancel button is clicked, the program should end. And then people Google, how do you end a program? And they find a method called system.exit. System.exit shuts down the Java virtual machine. And that will definitely end your program. But what else will it do if you call system.exit? It will shut down the test cases as well. So I'm trying to run test cases against your generator class, and the first test case calls one of your, runs your program, and it calls system.exit. The test cases are done. You won't get anything back because you killed the test cases along with the generator class. So don't use system.exit. If you want to end the program, you return from main. So when main returns, the program ends. That's how you end the program. I have also learned this weekend that grade scope, when you write to system.out, some of you are writing to system.out for debugging purposes. And that's fine. It would be fine, except for grade scope. What grade scope does is whatever you write to system out, it collects and displays it in the summary report. But I ran into a number of instances where the stuff that was being written out and when it was being embedded into what was displayed by GradeScope, basically causes GradeScope to crash. So it's a bug with GradeScope. The way to avoid triggering it is don't write anything to system.out. I'm going to complain to the GradeScope folks and try to get them to fix it. But if you have this experience where you ran your test cases for PS4 and what you got back was a completely blank answer that said 0 out of 30 or whatever, that's probably because you wrote something to system.out that caused GradeScope to crash. So just don't write to system.out unless I tell you to. Any other questions? Yeah?
I was just curious if the one-on-one TA schedule was working. Every time I click on it, it says I don't have access to it.
Okay. Yeah, it's working, but I forgot to set them up for this week. I'm sorry about that. So all right. Okay, I guess I just need to do them in advance. Sorry about that. I will do that after class. Any other questions? So you'll at least be able to do it Tuesday and Wednesday this week, so I apologize for that. Okay, so let's get into Eclipse for a minute here. And to do the dialogues class, not the dialogues class, the generator class, the user interface, you're going to need to be able to understand how to catch exceptions. And we talked about some of that last week, but we didn't quite finish. So I just want to quickly remind you about what we did and show you what we didn't do. So we have a series of examples of how, let me find the right spot here. Okay, this was the first example that we looked at. And it's an example, as it says up here at the top, of how an exception can be caught. So you remember, this is a try block. And at the end of a try block, you can put one or more catches. And what it says is, when you hit a try block, Java will execute the statements in the try block one after the other. If one of them results in an exception, then what it tries to do, if it's a number format exception, it'll get caught right here, and this code will be executed. If it's a null pointer exception, it'll be caught right here, and this code, which is nothing, will be executed. And what happens if it's an exception that's neither of the above? What if it's not a number format exception or a null pointer exception? What if it's an illegal argument exception? Yeah?
Will it say something like legal argument exception not caught? And then
Yeah, well, yeah, so the effect is, if there's no catch for the exception, then it's just like there's not a try block. The method ends by throwing that exception. And if it's the main method that ends by throwing an exception, then you see an Eclipse where it says unhandled exception. Okay? So normally, if we just did these statements without the try block, either of these exceptions would result in the program terminating. But by putting these catches in, we can tell, okay, that the user entered something that's not a number, and we can tell them. Or I think I just added that as an example to show you can catch multiple things. Right? So that's one example we looked at. That's how you catch exceptions. This one shows how they propagate. So here, we have show double input dialog. Now, up here it says, the comment for this says, throws number format exception if the user input doesn't parse as a double. So up here, when we call show double input dialog, it calls parse double. Parse double takes this input. That's that's in the Java library. Parse double says, this input is not a legal double. It throws an exception. So this method call right here could terminate in a number format exception. There's no try block to catch it here, so how will this method terminate? What happens when show double input dialog calls a method which throws an exception, which we don't catch? Does that terminate the program? Yeah. Okay. So he said goes up to main. So what happens is the exception is thrown by parse double. It's not called in this method. So this method here, show input dialog, terminates with that exception. So it throws the exception. Okay. Up here, main called show double input dialog, and so if it terminates with a number format exception, it'll be caught right here. So exception can be thrown by some method deep in the library, many method calls down, and be caught way up here in main or anywhere else along the chain. If it propagates out of main, though, that's when the program ends. That's when main doesn't handle the exception. Okay, so that was another example we looked at. This shows how to throw an exception. So I won't get back into the details of this, but basically, there was a situation detected, and the specification said that if this situation comes up, you should throw an illegal argument exception. And so what I've just highlighted is what it takes to throw an exception. There's the keyword throw, which is just like the keyword return. It's a keyword. Return says terminate the method by returning this answer. Throw says terminate the method by throwing an exception. Now, what's this part? What's happening there? How would you characterize that expression? What's the value of the expression I've highlighted there? Yeah?
So making a new illegal exception argument or object?
Right. That's just calling a constructor. We're calling the illegal argument exception constructor and creating an exception object, which we then throw. Okay? So it might you might wonder, what else can you throw? So let's take that out. Could we throw 17? Let's see what happens if we try. It says no exception of type int can be thrown. Okay, it's telling us 17 isn't something you can throw. Can we throw a string? It's going to say the same sort of thing. It's going to say no exception of type string can be thrown. So I'm not getting into the details today, but there are certain things that can be thrown and certain things that can't. But all the built-in exceptions in Java end with the word exception, so you can tell. So you have to create an exception object that you can throw. Now, you could do this if you wanted to. You could say illegal argument exception E gets this. You could create the object in one step and then throw it here. That would work. But I don't know anyone that does it that way. It's just extra typing. Yeah?
What's the difference between throwing new illegal argument exception and just throw normal? Can you throw an exception without the keyword new?
He's asking, can you throw an exception without the keyword new? And right here I show you can. The thing that comes after the throw has to be an expression whose value is an exception object.
No, I was asking like on the line above.
Hmm?
If you just E is equal to illegal argument exception, like just get rid of the new.
No, we're calling a constructor here. You can't do that anymore. You could, I mean, if you want to invoke a constructor, you got to call new. Yeah. You got to put to create a new exception object, you've got to say new. So anyway, that's how it's done. Create the exception object and throw it all at one spot. And I think this is the last one we looked at. It showed another use for the try block as a way of things that can be opened and closed, such as scanners. You can open them that way, and this is called try with resources. And then whenever control of the program exits the body here, whether it's by returning or throwing an exception, or it just executes past the end of this brace, then the resource, in this case the scanner, is automatically closed. And we'll eventually see lots of circumstances where you're opening things and you need to close them. And the best way is with this try with resources. Okay, so that was the basics of exception handling and try blocks that we looked at last week. Here's an example we didn't look at. So look at the main method there. What do you see that's new that we haven't talked about? Right. This here, throws file not found exception. So that's something that goes into the header. And this confuses students no end because of the similarity between the word throw and throws. Okay? They both sound like verbs. They are verbs. That's why it's confusing. And let me explain the difference. There's a big difference between throw and throws. First of all, you only see throws in the header of a method. Okay? You would not see throw. So that it's not going to like that. Similarly, you do not find throws in the body of a method. You only find throw. I don't think we have a throw here, but if we go back to where we did, it says throw. If we say throws, it's not going to like that either. Okay? So throw is a statement. Throws is something else. So let's go look at the something else. This is an advertisement to whoever calls main to tell them that it is possible that this method may terminate by throwing a file not found exception. So it just puts it in the face of the user. Yeah, they could read the specification for main if I'd written one and tell that it could terminate by throwing a file not found exception, but this advertises the fact. But it's more than an advertisement. If I take this out, I get a method. I get an error. And the error is unhandled exception type file not found exception. Here's the deal. There are two kinds of exceptions. It says right here. Checked exceptions and unchecked exceptions. The exceptions we've been using so far have been unchecked exceptions. Checked exceptions are required. If a method can terminate by throwing a checked exception, you must advertise the fact by putting throws in the header. File not found exception is a checked exception. And you'll see what happened when I took this out. The error message was unhandled exception type file not found exception. Two quick fixes. Either add a throws declaration or surround it with a try catch. So the bottom line is if you call a method that can throw a checked exception, you either have to catch it, or if you're going to allow it to propagate, you've got to advertise that fact in the header. It's kind of a weird rule, but it's there. So in this case, we're going to add a throws declaration. So sometimes the compiler will force you to advertise the fact that an exception may be thrown. It doesn't mean it will be thrown. It just means that it can be thrown. So a better thing instead of throws would be may throw. So it's just telling you, okay, this may throw a file not found exception, and since it's a checked exception, if it does, you've either got to handle it or advertise it yourself. So it's throws. And it's not a big deal, except for the first dozen times you see it. After that, get used to it. Now, things that are checked exceptions tend to be things that are out of the control of the programmer, such as file not found. That's external to the program. So errors with input and output tend to be checked exceptions because you don't have any control about the environment in which the program runs. So when you see that, for example, down here when I wrote longest token, the scanner constructor can throw a file not found exception. You can see it in the header right there. And since I'm not handling file not found exception down here, I have to advertise that fact right there. And then since main calls this method that can throw a file not found exception, we've either got to handle it or throw it ourselves. So that's that. And final example, or another example, we've already talked about this. This is a method that calls convert1. Convert1 calls convert2. Convert2 calls convert3. Convert3 parses an int and may throw a number format exception. So if we call this method, which calls that method, which calls that method, which calls that method, and this one throws an exception, this one gets a chance to catch it. If it doesn't, this one gets a chance to catch. If it doesn't, this one gets a chance. We already saw that sort of idea that exceptions can propagate back along the way things were called, or where things were called. So let me pause here and see. I've been talking a lot now. See if there are any questions I could answer about catching exceptions, which is absolutely crucial. You're going to have to do some of that in the assignment you got coming up. Yeah.
So this example shows where it has all the different calls. When it catches the exception, is it because it's throwing it back to main and main executes the exception?
Well, the way it's being called is when the exception is thrown here, then first thing that happens is we look for a try block to catch it here. There's not one, and so this method terminates by throwing the same exception. So when convert3 throws the exception and it's not handled, convert2 dies by throwing the exception. Same thing happens here. Exception is thrown, not caught, so it propagates. Convert1 terminates by throwing the exception. Finally, it's caught up here. We could have chosen to catch it down here, though I didn't. Yeah?
I'm a bit confused why parse int doesn't throw a no pointer exception. Well,
let's see. Parse int throws a number format exception. So you're wondering if you pass a null to parse int, why doesn't it throw a null pointer exception? I don't know. I guess it just throws a number format exception. Other questions? All right, let's look at a couple of examples that are very similar to what you'll need to do for your generator class. So this first method, its deal is it asks the user for a non-negative number. It then parses it, and then it displays its square root, and then returns. If there's a problem, such as a bad number was entered, then the exception, so parse double may throw a number format exception, and it gets caught right there, and we display a message and say try again. Well, a null pointer exception can occur if cancel is hit. Well, so what happens is show input dialog, if you hit cancel, it returns a null value. That will be stored in input, and we try to parse it. I think we do get a null pointer exception. So where does the try again come in? So if I run the program, let me run it here. I'll enter garbage. It says bad number, try again. Garbage, bad number, try again. 77, square root, okay. So what is it about this code that keeps it prompting over and over again? Yeah? Yeah. We're sitting in an infinite loop. So in interacting with the user, you've got no idea how many times you're going to ask the user to get it right. So I like to just say while true, then let's see what happens here in the body. Okay? Let's suppose everything goes correctly. The user enters an actual non-negative number, which gets parsed, the square root's displayed, and then what happens when we hit this statement? Method's over. Loop ends, method ends, and we're good. What if the user enters garbage and this parse double throws a number format exception? What's going to happen with the loop? It gets caught right here. We display the message, and what happens after we display the message? Right, we continue executing beyond the try block. We hit the end of the loop, and the loop repeats. Okay? If show input dialog returns null, and null is stored into the input variable, and then when we do the parse, we get a null pointer exception, it's caught right here, and what happens? The user hit cancel, and the effect is we end. So let's come here, run it again. I'm going to hit cancel, and the program just ends. Now, if you want to look, let's set a breakpoint here and run it like that. And step over this and go get let me hit cancel. So let's go back and see what happened. So I hit cancel now. So when I step over the next one, what's going to happen? What statement will I get to next? Okay, so because I hit cancel, I should get a null pointer exception, and so we end up down here. And that return ends the loop, ends the method. Okay? So take note of this. This while true structure that internally, if there's a problem that we're supposed to give the user another chance, we just display an error message and let the loop continue. If the right thing happens, we can either return or break out of the loop as necessary. And same thing down here. So you can either break from the loop, return from the method, or let the loop continue. So it's kind of a common kind of structure when you're dealing with users, trying to get input from a user. Okay? Now, how could we change this loop so that if the user enters a negative number, it doesn't try to compute the square root, but it gives them an error message? Mm-hmm. So what I mean is, suppose we first check here, if x is less than 0, what should we do? Yeah. One thing we could do is throw a new number format exception. That's exactly right. And what's going to happen when we do that? It'll get caught right here. And it'll say bad number, try again. So let's try that out. So I'm going to enter -5. I say OK. It says bad number, try again. Before, it would have done something different. Okay, and I cancel. What's something else we could have done here besides throwing a number format exception? Yeah.
Maybe a catch.
No, there's nothing to catch. So it's not a catch. Yeah?
Could you maybe just create a new dialog?
Yeah, we could have just do this. We could have chosen just to display the error message here and say, let's say, negative number. What else do we need to change about this method to make that work? Right, we don't want to then turn around and display the square root. So how can we prevent these two lines from executing when x is less than 0? Yeah, we just throw an else in here. So if x is less than 0, we display the message and let it continue, which will cause the loop to go. Otherwise, we display the square root and return. Yeah?
So, in cases where we're not calling methods that can throw something, rather than using a try catch formula there, we can use an if, throw, else, do it.
Yeah.
Okay.
Yeah. Either of these will work right here. We could, comment this out and put this one back in, and it's the same except the error message is bad number instead of negative. Either one's okay.
I guess what I'm asking is with that if else there, do we need the try loop at all?
You need the try because, so if I put it back like this, you need the try because parse double may throw a number format exception if you type garbage into it. And also it may return null, which I'm catching the null pointer exception here. The null pointer exception occurs here when you pass null to parse double. Okay? Let's look at one more, the last one. This is linecount.java. Okay, it opens a file from the user and displays the number of lines it contains. Okay? So let's see how that works. We open a file dialog, we create a scanner from that file, then we just have a loop. While there's a next line, we get the next line and increment count, and when we're all done, we display the count. So if I run that program, and it asks for a file, it tells me there's 22 lines. How could we improve this method? Yeah.
You can make it so that there's no issues if the user doesn't select the file.
Okay, let's see what happens. If the user goes here and just hits cancel, we get a null pointer exception because when we cancel, this method returns null. And when we try to create a new scanner from null, we get the null pointer exception. So how could we prevent that null pointer exception from appearing? I don't want my program to terminate that way. I want it to display some sort of error message. Yeah.
You throw a null pointer exception?
Say what?
You throw a null pointer.
Well, no, it's being thrown right here. It's thrown by that constructor. Catch it. So we could do this. And I said I want to display an error message, but really I just want the method to end if the user type cancel, hit cancel. So I just do that. now if the user hits cancel, we don't see that there's not an unhandled exception anymore. We catch the exception and ignore it. So I'll come here again. Oh, I need to cancel. So I'll run it and cancel. Okay, good. How else could we improve it? Mm-hmm.
Put in a well through and catch it so that actually displays an error message.
Well, yeah, we could put a loop around it in case there are mistakes a user could make that we want to recover from. And in fact, there is a possibility that the user could select a text file that can't be opened. So we could get a file not found exception. So we could catch the file not found exception and tell the user about it. But I had another thing in mind. We got this little warning that we never closed the scanner. How could we do that? How do we get rid of that warning? Yeah? What should I do? Yeah?
Can you put it up with the try? Because the try resources also serve as to cache things or in the same purposes, serve all purposes.
Yep, exactly right. So the a try with resources can optionally have catches on it. So that has the effect of opening the scanner so it'll be closed eventually, but also if there's an exception thrown when it's open, it will get caught down below. Now, what if we decided to catch the file not found exception? And maybe what we'll do when we catch it is say, display a message that just says bad file and leave it at that. Okay? We don't need this anymore in that case. There's no need to advertise that we're not throwing that exception anymore because we're catching it. So now if I run the program and I just type garbage in here and I'll try to open it, it'll just say bad file, whereas before it would have died with a null point, with a file not found exception. So you end up, what is it about all the programs we've looked at that made it necessary to catch exceptions? Yeah.
I have a question.
Okay.
So with the try loop, in the parentheses, do you have to have the semicolon after the scanner?
Oh. No, if you can, yeah, I guess it's optional. I just copied it up and left it there. So what is it about the last few examples we've looked at that makes it so there are lots of things we have to deal with? Yeah.
Dealing with like bad user data?
Right. Dealing with user data. Things can go wrong all the time. So that's a place where you often end up having to deal with exceptions. Or dealing with files out in the file system. Or dealing with network connections. Things go wrong there as well. And it's out of your control as a programmer. So you can't prevent these problems from happening. You have to detect them and deal with them. So you can take these examples and turn them into, be sure you look at these examples before you work on that generator class, because the ideas you need are all illustrated in these examples we just looked at. All right, let's take a break and we'll look at something completely different. All right, let's get started again. Okay, so I just had a good question, and I won't repeat the question, but here's the answer. There are three parts. There's PS5A, B, and C. But in terms of creating your starting point project, just do that for PS5A. B and C just exist so you can hand in pieces of their one project. So there's only one project, but there are three things to hand in. The Java API, the Java library, contains what are called generic collection classes. And when you program, you tend to make heavy use of these classes. So we're going to spend some time today learning what they are and how to use them. There are three basic kinds of things that are provided: lists, sets, and maps. And there are two kinds of lists, two kinds of sets, and two kinds of maps. The differences between those is not really important right now. We'll eventually talk about it. But the difference has to do with efficiency, mainly. Some of those are more efficient than others in varying situations. But other than that, they're interchangeable. So I'm not going to worry about the difference. So ArrayList, linked list, take your pick. I tend to use ArrayList. Let me explain how they differ, how lists, sets, and maps differ, though. That difference is important. So here's an example of a list, in particular an array list. So when you create an array list, it's got to be an array list of something. So this is an array list of strings. And you can think of it as an array, and it's indexed with integers starting at 0. So this one has length 6. It has indexes 0 through 5. At index 0 is a string, at index 1 is a string. But unlike arrays, they can grow and shrink. So you can add between index 0 and 1. You could add at the end, you can add at the beginning, or you can remove. So it's a dynamic list that can grow and shrink. Okay? So lists are good for, well, what are lists good for? How can you imagine using a list in a program? I think we talked about it last time, but let's repeat myself. Yeah? A list of data, we don't know how many they get. Okay, so imagine a program where you've got to keep track of all the people that belong to a club. Okay? So you don't know how many people are going to belong to the club, and people may join and quit at any time, so you use a list. One possibility. Okay, so that's a list. Lists are familiar to all of us. Now, we talked about the fine print last time, and I'll talk about it again. The only thing you can store in an array list or a linked list or a hash set or any of these collection classes, you can only store objects. You can't store primitive values. So you can't store ints. You can't store chars. You can't store booleans. So what we have to go through these manipulations in order to store things, to store primitives in a list. So let me remind you how you do that. So what you really want is an array list of ints, but Java won't let you do that. So you have to declare an array list of integers, which are objects. And then to put something in the list, you say you want to put 5 into the list, you have to turn that into an integer object that contains the 5, and then stick the object into the list. And that integer class is called a wrapper class. And when we use this constructor, we're boxing the 5 inside an object, and here we're not unboxing anywhere, but technically that's what you have to do to store a primitive into an array list. You have to first put it inside an object, and then put the object into the list. To retrieve it, there's a get method, so you say, give me the item at index 0 from the list. What comes back is an integer object. Then we've got to unbox it. We have to say, okay, object, give me the number you contain. Now we got it back. So that's a pain to have to do that. But what's the good news? Yeah? Right. It automatically boxes and unboxes for you. 99.9% of the time. There are a few weird cases. And so the only concession you have to make to the fact that these generics can't deal with primitives is when you declare it, instead of saying array list of int, you just have to remember to spell it integer with a capital I. And then everything should work as if these array lists could contain ints. So we don't have to do that. You know, we can. It'll do it automatically for us. And then you have to remember that if you want ints, you have to spell it integer. If you mean doubles, you got to spell it that way, and so on. Now we got an interesting question on Piazza, either last night or today, which basically asks, when should you use the int type and when should you use the integer type? And the answer is, use the int type whenever you can. And if the compiler won't let you use int, use integer. And the place where the compiler won't let you use it is when you're using a generic class. So your first instinct should be always to use the primitive type. If you get into the situation where you can't, use the wrapper class. Okay. Another kind of collection class is a set. So there are hash sets and there are tree sets. And again, they're generic, meaning you got to have a hash set of strings or a hash set of integers or whatever. What's the difference between a set and a list? People are really familiar with lists, comfortable with them. What's the difference between a list and a set? Yeah?
A set doesn't have an index.
Sets, right. So there's no notion of an index in a set. So you don't talk about, if you have a set, you don't ask a question like, what is it index 0? What is it index 3? A set either contains or doesn't contain something. And it cannot contain duplicates. So you wouldn't have 2 cows in this hash set of strings. Only one copy of each thing. So you may have a hard time thinking, when would I want to use a set instead of a list? But the answer is, well, it seems like you have lost things when you use a set compared to a list, because you can check, basically all you can do with a set is put things in it, take things out, and ask whether or not the set contains something. You can do all that with a list. Plus you get indexes. So why would you even bother with a set? Seems like a loss. And what you got?
I'm thinking of maps, actually.
Okay. Yeah.
Would you just use it for something simple as directories?
Well, you use it when all you care about is whether or not something is in the collection. You don't care where it is in the collection. You just know, is it in there or not? And by not providing indexing, it can answer questions about is it in there or not much more quickly than can a list. So it's an efficiency thing. You can get by without sets, but sets make programs fast sometimes. We'll see an example of using sets shortly. So there's your picture. Think of it as just a collection of things in no particular order. And you can ask, you can put things in, take things out, and ask whether or not something is in the set. And then here's a map. A map, notice that when you create it, you've got to give a key value pair. So what I've illustrated here is a hash map where the keys are strings and the values are integers. So in this map, cat is mapped to 15, cow is mapped to 4. So maybe we have a farm and we got to keep track of how much of each animal we have. So we have 15 cats, 8 dogs, 4 cows, and so on. So that's a map. What's a map in real life? Can you think of an example of a map like this in real life? That maps keys to values? Yeah.
Population, which states?
Okay, so if you have something that maps state names to population, that's a mapping, yeah?
Grades or roles.
Okay, grades, yeah? Inventory. Yeah?
UID code.
Okay. That can be used in a map, UID code. So, what about a dictionary, a printed dictionary? Is that a map? Yeah, it's a physical map. It maps words to definitions. What about the index in the back of the book? That functions as a map. It maps concepts or ideas to a list of page numbers that's discussed in the book. So you use maps all the time. So it's not surprising you use them in programs as well. So you've got lists, maps, sets. Here's another way to think about a map. You can think of it as an array where the indexes are the keys and the values are stored at locations. So think of it as an array that is indexed by cat, dog, cow, pig, rat, ant. So what's stored at index cat? 15. What's stored at index cow? 4. So that's another way to visualize it. You can visualize it like that, which is useful sometimes. Or you can just think of it as a bunch of pairs put around in a cloud. That works. Okay, so now we're going to write some methods using these classes. And the first one we're going to implement is one called getChars, which takes a scanner as input, and it returns a list of all the characters in the scanner in the order in which they occur. So we need to, what we're going to create to do that is an array list of characters, like that. So let's try to code that up. So let me take a second here and find the, go into Eclipse, and collections demo is where I want to be. Right here. Returns a list containing all the characters that occur in the input in the order in which they occur. So you see what I've written so far is we create an empty array list of characters. So look at that. I'm declaring a variable called allChars. It will contain an array list of characters. And this is one way to create a new array list of characters. Why don't I have to put anything in the angle brackets there? I could if I wanted to. If I spelled it right. Character. Technically, that's what you write. You say, give me a new array list of characters. If I leave it out, how does it know what kind of array list I mean right here?
You just assume you want to use one.
Yeah, it just figures out from context that you must be in an array list of characters. So it just saves a little bit of typing. Then we're going to write a loop that goes through our input, and as long as there's a next line, it grabs it. And when we're all done, we return allChars. So right here, we need to put some code that takes the characters out of the line and puts them into the list. How do we do that? How do we take all the characters out of the line and put them in the list? Yeah.
Add next character.
Say again.
Character add next character.
Okay, so there's a method called there's an add method that we could use, and if I do that, I've added x. So what that does is it modifies the list by adding x at the end. How are we going to add all the characters in this line, though? Yeah?
Could you do a statement?
Well, yeah, I'm going to need a statement.
Like and include, sorry.
Yeah, so how am I going to do that? Yeah?
Which is char.
Well, we can use char at to get something out. That's what's stored at index 3. So we need to take things out of the line and stick them in the list. But how do we do that? Yeah.
You use a string builder?
Well, no, we don't use a string builder because we're not building a string. We're building a list.
Accumulation?
What's that?
We're using accumulation?
Yeah, it's sort of like an accumulation loop. Right. We need a loop. So we just need to pull every character out of the line in turn. So I'm going to use a for loop. So we're going to generate the indexes into the string, and then what do we need to do? We don't want to add x. What do we want to add instead of x?
Char at I.
Yeah. So we don't want to add the char at index 3. We're going to do this. So I've just written a nested loop for the first time. So that's just saying for every line of input, iterate through it, generate all the indices into it, and pull the character out of the string, add it to the list. And then when we're all done with the loop, for completeness, we ought to do something like add a new line, because we don't get the new line out of the scanner, but we know there had to be one because it's reading a line at a time. And then we return that. So it returns a list containing all the characters that occur in the input. So we just used the constructor to create an array list right there, and then here we are adding to it right there and right there. We're using the add method. It adds at the end. Okay. Any questions I could answer about that? You're going to be using an array list of characters in PS5, so. Now, up here in the main method, I call something called analyze characters. Here, I actually open up Pride and Prejudice. I have a scanner that's reading from Pride and Prejudice, and I call right here that method we just wrote, and then what's going to get printed out right here? Right, the number of characters in Pride and Prejudice. So it's going to use that method we just wrote. So let's see how many letters there are in Pride and Prejudice. So there's 684,000. And that was pretty quick. And what would happen if in addition we output chars? What would we get? What's it going to show us? Every character in the book in a kind of a weird way. So let's run it. So that's how a list displays. It's just showing every character with commas in between them. So you may as well call it impertinent and so on. But that's a lot of output, so I'm not going to leave that in there. Now, it's interesting that there's so many letters in the Pride and Prejudice, but some of them Jane Austen used more than once. She probably used the space character more than any. How could we find out how many distinct characters? That's what it does next. It prints out the number of distinct characters. As you know, how can we get rid of the duplicates? Yeah. Okay, so whenever you're faced with a situation where you've got duplicates and you want to get rid of them, one thing to consider is just make a set out of all those elements. And sets don't allow duplicates. If you try to put the same thing into a set twice, it's as if you only put it in once. So I've got this method now called getChars. So let's go to it. And let's see what we can do. So this creates a tree set of characters and returns it. So it returns an empty set. Well, there is a constructor for tree set that can take any collection. So just by changing the program in that way, what I'm doing is I'm creating a new tree set that contains the same thing as that list that I'm calling chars. And then I return it. Now, and I'm claiming that the number of distinct characters in the book is going to be equal to the size of that set we just created. Why is it going to work? What happened, if chars contains 10,000 space characters and we insert all 10,000 into this set, how many space characters will the set contain? 1, because it ignores duplicates. So without writing a loop, just by using the power of the data structure, that it can consume an entire collection like an array list. And so it's as if, what's happening in this constructor is it's looping through the list, putting every character, adding every character to the set. Now when we run, we can see character count, and then there's 75 different ones. And somewhere I've written code that's saying, okay, there's a line feed, there's a space, there's an exclamation mark, there are all these digits, there are all these capital letters, all these lowercase letters, but there's 75 different ones. So that's the power of a set. One power is to get rid of duplicates. Let's go up and see where I printed this out. Okay, look at this loop right here. So I am calling getDistinctChars, and I get back a tree set of characters. And then I'm printing out, there's a class, in the character class, there's a method called getName that prints out the official name of the character. And I'm just doing that. Do you see anything that I've never talked about in that loop right there? Yeah. Okay, an enhanced for loop, or a for each loop. So I've had you read about this, but the way it looks is there's for, and then parentheses. You typically declare a variable. You have something here you're trying to iterate through, and then you have a colon right there for each loop. So that's the only way to iterate through a set is with one of these, because you can't index into a set. You can't generate indices and then look up what's at index 0, 1, 2, 3. So you iterate it through like this. You can use the same trick for going through an array, and you can use the same trick for going through a list, a for each loop. It just gives you, each time through the loop, you get another character from the set. And then when you've received every character in the set, the thing terminates. So all I did was write a loop that prints out the identity of every character in the set. So use those kind of loops whenever you can. They're simpler than other types of loops. Okay, let's look here. Returns an upper bound in the number of sentences by analyzing a list of characters from the book. Okay, so how can we sort of approximate the number of sentences in the book? What can we count? What's that? Yeah, we count the number of periods. Or maybe we ought to count exclamation marks and question marks. Now, why is that? That's going to be an overestimate, though. Why is it an overestimate? Yeah?
So dialogue.
He said because of dialogue, or I was actually thinking of like Mr. Darcy has a period in it, but that's not a sentence. Dot, if there are any ellipses in it. But at least give us an upper bound. So what I'm using here, remember, look, we're getting in a list in as a parameter. That's a list of all the characters. It's, 600,000 characters long. We're going to loop through it like that. Just say, okay, for each character, do something. What do we do? When do we add one to count? Yeah?
Character is a period.
Okay, so if C is okay, now how can we deal with question marks?
Use the or.
Right, we just do the or operator. So I'll come here and I'll say or. So if it's a period, or it's a question mark, or it's an exclamation mark. If any of those things is true, increment count, new and return count. So run the program now. There are about 7,000 sentences, according to that estimate. Okay? So we're basically writing programs, pretty simple programs, to deal with, the pretty long book here. It doesn't take a whole lot of effort to get it to work. Okay, let's turn to a different example. So what I've been doing is analyzing characters. Let's analyze the words. So that's another method down here, analyze words. And first thing it does is count the number of words. So it calls a method getWords and displays how many words there are. Well, how are we going to do that?
Space.
Say what?
White space.
Well, we could count white space, or I had in mind something different using a scanner. How could we use a scanner to approximate the number of words? Yeah? Yeah, just use get next. Just loop through and get tokens, count tokens, in other words. So let's go down here and count words. So let's see what I've got. I loop through the scanner. I get the next word. I convert it to lowercase. And if its length is greater than 0, which I don't know how it can't be, I add it to the list. I know how. There was some code I deleted that could have made the word empty. So let's try that out. So it found 12,000 distinct words, and let's look at some of them. Now, do you see the problem here? It counted yesterday, yesterday, comma, yesterday, period, yesterday, that, yesterday, semicolon, as separate words. So what would it take to do a more thorough job here? That's the code I deleted. What would it take to get a better estimate of the number of words? Yeah? Yeah, we'd have to have some code. So you notice one thing I did is I took the word and at least I converted it to lowercase. So it's not treating a word at the beginning of a sentence as capitalized any different from a word in the middle of the sentence is not. But I could also add code here to strip off, say, periods at the end or commas, punctuation, and try to do a better job. But that doesn't advance my case of explaining how ArrayList work. It'd just be some more string manipulations. So that's good. This returns all the distinct words in the list. Okay? So it takes the words in a list form and returns a set made from those words. And in fact, I think that's what we were actually seeing. These are the distinct words. So there's 12,000 distinct words. And it scrolled off how many different words there were. There's a limited number of characters I can put in here. Okay, here's one last one. See if we can do it in the time we have. I want to create a map. I want to take in a list of words, and I want to map every word in the list to the number of times it occurs in the list. So I'd like to find out that the occurs 500 times, and that Elizabeth occurs 200 times. And to do that, I'm going to create a map that maps words to the number of times they occur. So I'll start the loop. We want to consume the entire list, so we use a for each loop. What should we do with each word? Let me give you a picture here. That's not right. That's what we want. So I want to create a map that maps the to 52, say, and pumpkin to 1, hers to 15. So the keys are the words, the values of the number of times the word occurs in the list. So, with that in mind, what do I need to put right here inside the loop? What do I do with each word that I find in the list? Yeah? Okay. So he's suggesting maybe we look at the map, and there's this method called contains key. So if it already contains a key, if word is already a key in there, we're going to do one thing. Otherwise, we're going to do another thing. Suppose that the map is brand new and it's never seen the. The is not a key in the map. So we're down in the else case. So we need to store the into the map. With what frequency? How many times have we seen the so far? One. So we're going to say word count. And the method is called put. The key is going to be word. And the number of times this occurred is 1. Okay? Now, what if we've encountered the, and it already is in the word count? There is already a the stored into the map. What do we want to change about the map? we want to take, let's say the map currently says the occurs 50 times. We want to change it so the occurs 51 times. So I'm going to do it this way. I'm going to, that's not, so word is my key. I don't know why it's doing this. And I've got to put the new value there. Well, the new value is going to be, I'm going to use the get method to find out how many times, what number is currently stored next to word, and I'm going to add 1 to it, and then put it back in there. So to summarize, I say, okay, map, how many times does that word occur currently? I get that number, I add 1 to it, and then I store that number back into the map. And if you run that, before you run off, you can see that yourself occurred 28 times, young occurred 126, written occurred 17. Okay? So I'll stop there and see you next time.